let's just go over a few more settings. Be interesting. If any of you are still awake, then great. If you're all asleep, then sleep tight. Dwell battery protection, correction even. Basically, this is the standard dwell correction table that MS uses. This is standard for inductive coils. I would leave it well alone unless you know what you're doing, but this can all be changed, and in MS2 it can also be changed. Let's just open an MS2 project up again. For some reason or other I seem to have stopped one. Dwell battery correction, same values, same thing in MS2. Leave that well alone though, but that's what it should be. If you have messed about with it by accident, the values it should be. You've also got cold advance. Now this is whilst the engine is colder, the coolant temperature will be colder. You can increase the advance over the entire spark map. This can help increase the engine temperature quickly, and also aid, if you increase the advance of an engine, the engine speed increases. So at idle, if you increase the advance slowly, the engine will increase as well. So you can add a few degrees to the table when the engine's cold to aid engine idle speed and to help it warm up a bit quicker. You don't want to add too much, but just have a little play of it and add a little bit. But the main thing is once you get to 70 or 80 degrees, wherever your engine is at, once it's warm, make sure you've got 0 in there. Because if you had a 7 in there, or 6 or 0.4 or whatever in where your engine normally runs at, the whole table will be offset by that value. So make sure that when you get to 60 or 70 degrees or 80 degrees C, wherever your engine is at, make sure that's a 0. Otherwise, if the engine cools a little bit, that go into that, back into that, and you'll start adding advance. So that just adds a little bit of advance to the whole ignition table. Don't mess about with this until you've actually got the whole engine tuned, that everything's tuned. These are settings that should be played about with once the engine's tuned, because otherwise you might find that your AFRs are a little bit out and you start getting too confused. Manifold air temperature mat based timing retard. This is in MS2 as well, same as the other one. MS2, MS3, and in MS1 some of this is in. Basically you can start to pull some ignition out of the timing if the inlet air temperature gets too hot, because as the air temperature increases, the likelihood of detonation increases. Pinking, detonation. So if you find that under normal running the engine's fine, but if you've been sanding traffic and you put your foot down after a little while and it detonates, so you get a little bit pinking, look at the engine, the manifold air temperature sensor value in the data logs, see when it peaks or when you get the detonation, and you can pull a little bit of timing out of the whole table, whole spark map, depending on the manifold air temperature. I've got a supercharged engine, and I found once I get to about 45 degrees C, I get a little bit of detonation. So I've started pulling out a little bit early, and come 45 degrees, I've pulled out 3 degrees, and that seems to work really well with mine. If I do get up to 50 or 60 degrees, I want to start pulling quite a bit of timing out, because you should never get up to them sort of temperatures anyhow. But if I am up to them, then I want to pull some timing out. But that's over the entire map. So if you've got an idle advance of 8 degrees and you pull 8 degrees out, you're going to be idling at 0. So you've got to be a bit careful how much you pull out. Excuse me, I've got a cold. Noise filtering. This is pretty specialist, and there's quite I can't explain it very well, but I tend to leave this on, the primary on, and just with these settings in them, seems to work reasonably well. I don't have any problems, so but you can do all sorts of filtering with from the trigger inputs. So you can turn on a mask for so many milliseconds and cover a certain percentage, and you can also this is to if false triggering on the crank signal. Most of this should be covered by trying to eliminate noise externally rather than via the software. But this is here if you need it. But there is quite a good description of this on the forums, on the websites. Knock sensor. Okay, this MS3 has slightly different method to MS2 and MS1 in that you can have an analog input rather than an on and off input. On-off input is where I sell the knock conditioner units, and they just give a pulse every time it every time it decides that it's seen knock or heard knock. The knock units that I sell drop the input to 0, so knock input would be on and off. And then depending on which input you use, depending on how it's wired in, probably Jazz 4, Jazz 5, you then select that. Knock indicated by normally that's going low, so low input. Certainly on knock conditioners I build, that would be low. Pull up, make sure the pull up's on, so that the microprocessor itself holds that pin high, and the knock sensor module conditioner unit thing will pull it low. So pull up, and then so the internal pull up is on, pull up, and the knock unit will pull it down when it sees knock. You can have a window if you want to say that an output come on to say it's detected knock, and then this is how many knock counts it sees before it starts ignoring, before it starts before it starts to retard the ignition. So basically this system retards ignition maximum depending on how much knock it sees. So the more knock it sees, the more it will retard the ignition. After up to a time period, then it'll start advancing the ignition back to where it was. There's aggressive mode and safe mode. Aggressive mode basically means it takes it back to where it was. Safe mode means it will take it back to a specified amount, so you don't go back. So if you say pull 4 degrees out, you can have it so it only goes back 2 degrees. So you've always got 2 degrees missing. Generally speaking, aggressive mode is the one to use, so it goes back to where it was. The analog input is if you directly connect the ECU to the knock sensor, but you would need to modify the board a little bit because there's filtering on the board, and you need to modify the board in order for that to work. But I've done that, and that works reasonably well. But you need a better filtering circuit really to get rid of any noise, but this is how I've set mine up in the past. And then you've got an internal knock system that James Murray's developed. Very, very good. It's got probably the ultimate in that's got a programmable filtering system, but you need an MS3 to run that system. So for MS2 and MS1s and most MS3s, you could use the analog or on and off. I'd use the on and off. But if you want to, and you want to buy one of James's units, then there's an internal system, and that has its own program and setup. Okay, these are just the windows, self-explanatory. Windows high, low, maximum retard, how often it checks it. How much it steps, how much it retards the ignition. So the first one's the coarse, and then the next one will be the fine. So the first time it sees it, that'll pull out 2 degrees, and then if it carries on seeing it, that'll pull out whatever you've set in here. So 1 degree if you want to, or 2 degrees. And then after half a second of not seeing any knock, that'll slowly advance again. So I've put in 3. I want mine to advance it in 3 degree steps back again. This table here is the percentage of knock that the analog system sees, or the digital system sees. If you're on an on-off signal, then 100% would be no knock, 0% would be some knock, so there's no in between. So you could set all of them windows at 20%, because it's on or off, so it would be either 100 or 0. With the analog system, you can allow it to detect a certain amount of noise before it switches in the knock system, so you generally have that a little bit lower at low RPM and higher as the RPM increases, because you're going to get a lot more valve train noise and a lot more noise, piston slap and the likes, as the engine speed increases. You want to try and filter some of that out by increasing the amount of noise, the level of volume that the ECU triggers out. Then we've got a window. This is quite clever, very clever in fact. The theory is that knock only happens after top dead center, and only for a small amount of time after top dead center. And so if you see any noise, if the knock sensor sees any noise just before top dead center, it's not knock, it's something else. So what they've added for MS3 is a window to allow you to only look at the knock sensor. So it starts at 0 degrees here if you wanted it to. So in theory that they should all be 0 degrees. So top dead center, and then the window that it looks for in needs to be quite large at low RPM and slower and lower at higher RPM. This is very difficult to say what's right and what's wrong, because different people have different opinions on it. These are the values I've entered, and I've seemed to find they work reasonably well. But the deeper the theory goes, the more you tend to get into it deeper and deeper, and you'll probably end up with different values. But they seem to work reasonably well. And not coolant scale. So this is how much knock's needed, or how much the percentage is added to the knock system when the engine's cold. Main reason for that is because you'll get a lot more noise and knock when an engine's, or a lot more noise, sorry, not necessarily knock detonation, but you get a lot more noise when the engine's cold, because the engine's got wider tolerances and be chatting around a lot more, so you can alter the scaling